I'm Xinxin Fan, head of cryptography at IoTeX. Today we're talking about the blockchain and IoT, especially from the research perspective. During the process we are building our product. Here's today's agenda. I will give a very brief overview about the machine economy. Then list 5 categories of research challenges we have been facing on during the product development process. Also share some of the research tools. We have open source research tools we have been built. Hopefully this can help advance your research career. Okay, let's get started. Firstly, brief overview about the machine economy, why we think it's important. Traditional Web 2-based IoT system, like we're all aware of, is a centralized system. You usually either deploy your application in a cloud environment, or you apply some edge computing framework to build your edge computation applications. So basically, it's largely centralized systems. The value chain for this type of system is quite straightforward. Starting from the device manufacturer, you need a system integrator to help you to build the entire system and then deliver the value to the customer. So this process is quite straightforward. But since the occurrence of blockchain, right? So we have seen during the past years, people already thinking about how to basically doing all kinds of applications using financial assets as well as the real world assets, right? So we already see this revolution for the past few years. 2020, it's starting the year of DeFi, right? So we see all kinds of DeFi applications based on the data available on the blockchain. It's quite makes sense because at that time the huge amount of data available for developer is the data sit on the chain, right? So after people think, okay, we can build all kinds of financial applications, how about control other type of assets, right? So that's why we see 2021 is called the year of NFT. People starting looking at how to tokenize other type of assets, like the collectibles, arts, other things, right? So since 2022, as a Web3 community, we're starting to think about how we can build other type of applications, which can affect people's life, right? So that's why we call it the rise of MachineFi or machine economy. So basically, the idea is that how about we bring the machine data and utilities, we tokenize those assets and bring them to the blockchain. So in this way, since IoT across multiple industry sectors, we can all kinds of IoT devices and machines have their own utilities, which immediately open a larger space. We can actually build the application on top of that. Okay. So what is exactly the machine economy? According to the definition by Next Big Thing AG on their 2022 report, machine economy essentially, we all know the machine has their values in terms of the generated data as well as the utility itself, right? So how about we tokenize those two aspects of the machine and make them become a valuable asset for people and for developers, also for the entire community. There are 3 key pillars for building machine economy. First one is the Internet of Things, or IoT, right? So the reason is that IoT can help us to capture what's happening in the real world in real time. Also give us the opportunity to tokenize the data captured by the IoT device, as well as the utility provided by the machine. So essentially, once you tokenize those things, you can build a marketplace using either data or the utility of the machine. Yeah, second pillar of enablers is a distributed ledger technology, or DLT. You can use blockchain or other type of DLT, right? So this one I don't need to explain more. You can do the transactions without trusted intermediaries. Most importantly, the blockchain or DLT introduced an element of finite supply, so which enable the developer to create what we call internet of value, right? So when it's have a limited supply, the value will be changed depending on the supply and the demand side. The third pillar, also very important, is tokenomics, right? So with a proper deploy of a tokenomics scheme for machine economy, actually you can solve the cold start problem for the stakeholders inside the system. For example, the device manufacturers. And on the other side, you can address long-term sustainability issues with a proper tokenomics model. I think that this three aspect, I think that's a key enablers for any projects building the machine economy. Why it's become interesting? Like I mentioned before, traditional Web 2-based IoT business, the business model is quite simple. You along the value chain, you can generate the revenue from device manufacturer until the end users, right? But introducing the blockchain and the token models actually open the door for new business models that will affect that has attract a lot of attentions from the IoT system stakeholders. Basically, they can try the different ways with their product or with their system. For example, device manufacturer, as you can see from this picture, actually, instead of directly manufacturing a huge number of devices, they can actually create a machine DAO. Actually, they can attract like community members or institution investors, all those members to form a DAO, doing the pre-investment. Okay, by assigning by have this DAO structure, they can define how those individual investors can get the rewards at a later stage. Other system stakeholders, they can doing the similar things. Basically, with token models, you can coordinate or align the benefits for all the stakeholders in the system. So that's why this topic become interesting to traditional IoT business. Now they have new business model or customer engagement approach they can explore to boost their business. So from the high-level system architecture perspective, actually, in order to build a MachineFi or machine economic applications, we need to have these three pieces, right? So on the left side, we have all kinds of IoT device we need to deal with to capture what's happening in the physical world. In the middle, we need to bring those insights into blockchain. You can either use a layer 1 blockchain or layer 1 plus layer 2 blockchain to address this issue. That's really depending on your application specifics, right? So as we know, the IoT device will generate a huge amount of data. If you put all the data on the blockchain, definitely it's not feasible. But if you have the data generated with a very long-term period, you want to directly send smart contract, that might work. But for most of the general purpose cases, when IoT device generate a huge amount of data, especially in a relatively high frequency, the layer 2 is the way to go. Okay. Based on the insight blockchain has been collected, the smart contract will be triggered. So to doing the token distribution, to doing the reward distribution, so you can build all kinds of decentralized application based on what's happening in the real world. Well, from the high-level perspective, this architecture looks simple, but for building the real-world system, there's a lot of complexity. Actually, there's a short primer about machine economy I co-authored with experts from the Siemens. If you are interested, it's published in the Industry IoT Consortium. You can take a look. It's just a very short primer about machine economy. Okay. So during the way we're building the machine economy systems, actually there's a lot of research challenges. I would like to share with you this basically is an IoTeX solution, how we can build this MachineFi system from end to end. Right. So what this is actually our layer 2 solution called Webstream. The main purpose of building this is to connect smart device to the smart contract. Yeah, you can see from here, the Webstream is actually the off-chain computing infrastructure. They can convert real-world data from the device into an insight that is verifiable and chain agnostic and DApp ready. Those type of proofs will be fit into a smart contract to enable all kinds of machine economy dApps. In the middle is actually a community-driven, decentralized Webstream network. Like all the other blockchain projects, this need to go through multiple stage iteration from the single nodes until eventually get involvement from the community members. I summarize actually 5 categories of research challenges we have been facing. Those challenges actually either being addressed by our team internally or through the collaboration with external researchers and universities, or through the collaboration with other blockchain projects. Yeah, the first category actually is the device management, right? So we know all the device management in the IoT system currently through the centralized way. But if you want to move all those IoT devices to the blockchain world, device management become a big issue, right? So essentially, you need to map the real world identity of those devices into some kind of identifier on the blockchain. So in our case, we use the decentralized identifier or SSI technology to represent every single physical world device or machine. Okay. But how to onboard those devices, how to band those devices with its owner is already categories of the research challenge. Yeah, second category is that how can we create like the DID or self-sovereign identity techniques for the smaller IoT device, right? To address this challenge, actually, we started this initiative to build an embedded SDK for all kinds of bigger or smaller IoT devices. We basically follow the best practice from the ARM. We use a PSA cryptography API, which will simplify the developers work when they are trying to use all kinds of crypto functions. Actually, you can also bring your own crypto library to integrate this SDK. On top of that, we are exploring the development process for adding the identity and credential layers as well as the DID communication layer. So these 2 layers will enable your IoT device to interact directly with a decentralized network. Unlike the Web 2 case, right? So you know who you are going to talk to. You can basically download a certificate to have initial trust. But for decentralized work, definitely there's more involved. Yeah. Third category of challenge is off-chain computing. Actually, we built this off-chain computing structure based on the WebAssembly runtime, which can allow the developer to build flexible business logic, convert them into a WebAssembly module. Then you can load this module into the runtime to interact with the device. All the communication or events from the device from blockchain will be monitored or managed by an event manager. Yeah, the fourth one is about generating proof, right? So once we grab the data from the real world and being processed by the Webstream network, some kind of a proof needs to be generated. So there's a number of approach. Actually, there's different options you can explore here. One is to generate a zero-knowledge proof to show what's really happened. For example, you have walked more than 10,000 steps for the past day. The other one is to explore the trust execution environment. Essentially, if your nodes support like the Intel SGX, AMD SEV, and other type of TEE, you can by generating a attestation report, a remote attestation report, you can realize a similar function. Another one is MPC. You can also explore this function to generate some kind of proof during the collaboration process among multiple nodes. Yeah, final part is tokenomics. Of course, it's a very important topic to align all this, align the benefits of all the stakeholders. If you are working on the mathematical modeling and have some financial background, that's a really fantastic topic. think that, yeah, those are 5 categories of topics we are actively exploring. And if you are interested, feel free to reach out. We are quite open in terms of collaboration. Yeah, finally, I just want to list a few tools you can use for your research. First one is like open hardware we have been built. It's called Pebble Tracker. Actually, it's a smaller device, but yeah, with a bunch of sensors, but including GPS all the climate sensor, motion sensor, etc. Most importantly, this chip has a very nice security feature. You can explore the ARM trust zone, crypto cell. It's all from the ARM. Basically, you can build the trusted IoT applications. It's a collaboration with the Nordic Semiconductor. And yeah, this one's firmware is open source. You can do all kinds of customization. Yeah, in terms of our platform, actually, it's a suite of tools. We have layer 1 blockchain with like 5-second blockchain block time instant finality. Also layer 2, there's all kinds of middlewares to doing the cross-chain communication, the self-sovereign identity, Webstream, this layer 2 network you can use. Also, there's a Explorer wallet. Everything is open source. Think I left all the links here. You can take a look for the developer resources. If you have any questions, feel free to reach out. We are expecting to collaborate with all the researchers here. Thank you.
Yeah, thank you.